Right, this is Unit 8, Lesson 5, Polar Form of Complex Numbers. So our lesson essential question is, how can you use trigonometry to represent and multiply complex numbers? At the end of this lesson, you'll be able to use the polar form of complex numbers to calculate products and powers. Example 1, represent a complex form number in polar form. How can you use modulus, and directions to locate a number in the complex plane? Consider the segment connecting the complex number z equals a plus bi to the origin. The length of the segment r is the modulus of z. The angle theta measured counterclockwise from the positive real axis to the segment is called the argument of z. Okay? So the angle measured counterclockwise, so right here is theta, because here is the positive real axis to here. Okay? And then the line segment is called the argument. You can use r and theta to correspond to z in the complex plane. Z equals a plus bi. Well, r cosine theta plus r sine theta I. Using trigonometry, you know that the length a equals r cosine theta and the length b equals r sine theta. Okay, based off of this, so r cosine theta, r sine theta. So I factor out an r, which gives me r times cosine theta plus I sine theta. Z equals r times cosine theta plus I sine theta. You can use the notation cis theta as shorthand for cosine plus I sine theta. So z equals r cis theta. This is the polar form of a complex number for z. All right, let's try it. Graph the complex number cis pi over 4. Remember, this is cosine pi over 4 plus I sine pi over 4. The cosine and the sine of pi over 4 are the square root of 2 over 2, which would put me about here. Okay. So you can see a cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 4 is the square root of 2 over 2. All right, for the second try problem, I have 2 cis pi. So this is 2 cosine pi plus I sine pi. Remember, that's how we're talking about it. So if I'm looking at cosine and sine pi, that's going to put me over here into -1, 0. So my cosine is -1, my sine is 0 for pi. Okay, but I have a 2 out in front, so I'm just going to multiply that answer times 2. So I start here at 0, and then I'm going to go to -2. All right, example 2, convert between rectangular form and polar form. How are the polar form and the rectangular form of a complex number related? How do you express z equals 5 cis 3 pi over 4 in rectangular coordinates? So we kind of looked at this a little bit earlier when we were talking about graphing them. So you can actually see the coordinates that were used. So when we had pi over 4, or pi over 4, we used square root of 2 over 2 and the square root of 2 over 2. Those are the coordinates that we remember from the unit circle. So I have 5 cis 3 pi over 4. So remember that this is 5 cosine 3 pi over 4 plus I sine 3 pi over 4. So I'm going to go ahead and look at where 3 pi over 4 actually is on my graph. So that would be, here's pi over 4, 2 pi over 4, 1 or pi over 2, and then 3 pi over the 4 would put me in my second quadrant. So identify the values of r and theta. In this example, r equals 5 and theta equals 3 pi over 4. So z equals a plus bi, where a equals r cosine theta and b equals r sine theta. So I have a equals 5 cosine 3 pi over 4. So I have 5 times the square root of -2 over 2, which equals -5 square root of 2 over 2. And then for b, I have 5 sine 3 pi over 4. Well, 3 pi over the sine of 3 pi over 4 is square root of 2 over 2. Again, those are the points that I have. Remember these from the unit circle. So I multiply that times 5. So I have 5 square root of 2 over 2. So expressed in rectangular coordinates, z equals negative 5 square root of 2 over 2 plus 5 square root of 2 over 2i. Don't forget that I in the last half. Remember, that's what the cis stands for, so the I is that imaginary number. How are the polar form and the rectangular form of a complex number related? So B, how do you express z equals negative 7 minus 4i in polar form? Graph z on the complex plane to help you find the polar form. So we had negative 4, or negative 7 across, and then down to negative 4. So this is my alpha, or my theta is this blue. So from this x-axis all the way to my new angle that's formed. And then this is alpha. So I find the modulus. So r equals the absolute value of z. And to find z, I take negative 7 squared plus negative 4 squared, and I square root all of that. So it's the square root of 65, which is approximately 8.06. To find theta, use a reference angle alpha, where the tangent alpha equals negative 4 over negative 7, or 4/7. So alpha equals the inverse tangent of 4/7, which is approximately 0.52 radian. Since the terminal side of theta is in quadrant 3, theta is between pi and 3 pi over 2. So theta equals pi plus alpha, which is 3.66 radians. Okay. So the polar form of z equals negative 7 minus 4i is about 8.06 cis 3.66. Okay. So remember, pi is approximately 3.14, which is where they got this 3.66 from. Okay. So to go over that again, you take these two numbers, you square them, and then find the square root. Okay. Then using that, I have to make sure you graph it. It'll be a lot easier if you graph it. Okay. So that way I can find, that way you found this length right here. Okay. And then I have the tangent. So again, we're finding theta. So we're going to use that reference angle where tangent of alpha equals negative 4 over negative 7. So remember, the tangent is your cosine, is your sine over your cosine. So negative 4, negative 7. So again, those negatives cancel each other out, gives you a positive. So I'm finding the inverse of that tangent of 4/7, which is where I get the 0.52 from. Okay. And then that 0.52 is this alpha. I still have to add the pi plus the alpha because it's in quadrant 3. All right, let's try it. Express 4 cis pi over 3 in rectangular form. So again, I'm going to look at this pi over 3. Pi over 3 is what I want to look at. So I have 4 cosine of pi over 3 plus I plus 4i sine pi over 3. That's what that actually stands for. So cosine of pi over 3 equals 1/2. The sine of pi over 3 equals the square root of 3 over 2. So then I'm going to multiply each of those answers times 4. So 4 times 1/2 plus 4 times the square root of 3 over 2i. Okay, 4 times 1/2 is 4 times 1, which is 4, divided by 2, which is 2. So 2 plus 4 times the square root of 3 is 4 times the square root of 3, and then divided by 2 is 2. So 2 square root of 3, and then I have 2. I'm going to add the I in front, because otherwise it gets kind of confusing. So I have 2 plus 2i times the square root of 3. Okay. For B, I'm expressing 5 minus 5i in polar form. So I want to go ahead and graph this. So remember when we graphed -7 and -7 minus 4i, I went this way and then I went to the left, my left, down. Okay, so 5, I'm going to go to the right and then down, which puts me in quadrant 4. Okay, so when graphed, puts us in Q4, so quadrant 4. Okay, so then I'm going to take those two numbers, so R equals Z. So this equals the square root of 5 squared plus -5 squared equals the square root of 25 plus 25, which equals the square root of 50, which is approximately 7.07. Okay, so then I want to find tangent theta. Remember, tangent theta is my cosine divided by my sine. Or my sine divided by my cosine. Divided by my cosine. Okay, so our sine was -5 over 5, which is -1. So I'm going to find the inverse tangent of -1. So the inverse tangent of -1 is -45. Sorry. Had it in degrees and not radians. So it's -0.18. Approximately -0.79. So then, remember it's in quadrant 4, so I add 270 to that. So my tangent is still going to be negative, but I'm adding, this is just my reference angle. Okay, so that means I'm going to add 270 to this. So 270 plus 0.79. So about 270.79. So I have 7.07 cis 270. I could actually also keep this in like pi over 4 and things like that. So that would actually be, so this would be 25 plus 50. So I could actually just simplify this. So this would be the square root of 25 times 2, which is the same as saying 5 times the square root of 2. So, and then I get a tangent of -1 when I have 7 pi over 4. So now, okay, so instead of 7.07, I could also have 5 square root of 2 cis 7 pi over 4. Okay. What patterns do you notice when multiplying complex numbers in polar form? So multiply a few example numbers to find a pattern. Suppose z sub 1 equals 2 cis pi over 4, z sub 2 equals 2 cis negative pi over 4, and z sub 3 equals 3 cis pi over 2. So I first multiply z1, z sub 1, and z sub 2. Okay, so when I do that, I get 4. Okay, it was 4 square root of 2 over 2 plus I square root of 2 over 2 times square root of 2 over 2 minus I square root of 2 over 2. 2 times 2, remember, gives me the 4. So when I simplify this, so when I actually FOIL this out, I get 1/2 plus 1/2 because the i's cancel out. Remember, I times I, or I squared, is going to give you a -1. Okay. And then I have 4, so 4 times 1/2 plus 1/2, which is 4 times 1, which gives you 4. Since 4 is on the real axis, theta equals 0, so z sub 1, z sub 2 equals 4 cis 0. Next, multiply 2 z sub 2 times z sub 3. So remember, 2 cis negative pi over 4 times 3 cis pi over 2. So that gives me 6 cosine negative pi over 4 plus I sine negative pi over 4 times cosine pi over 2 plus I sine pi over 2. Okay, so that gives me 6 times square root of 2 over 2 minus I square root of 2 over 2 times 0 plus 1. When I go ahead and FOIL this out, I will get 6 times square root of 2 over 2 I plus square root of 2 over 2, which I can just rewrite. So this is cosine of pi over 4, and this, all right, that gives me 6 times cosine pi over 4 plus I sine pi over 4, which is 6 cis pi over 4. Okay. The last one I'm doing is, notice for z sub 2 equals 2 cis negative pi over 4, and z sub 3 equals 3 cis pi over 2. Z sub 2 times z sub 3 equals 6 cis pi over 4. So z sub 2 equals 2. So I'm multiplying the numbers that are out in front, 2 times 3, and then negative pi over 4 times pi over 2 when I add those together. So I have 2 times 3, so I multiplied the numbers that were out in front, and then I added the 2 numbers that were inside the cis parentheses. So negative pi over 4 plus pi over 2 gives me the pi over 4. Similarly, z sub 1, z sub 2 is 2 cis pi over 4 times 2 cis negative pi over 4, which is 2 times 2, and then pi over 4 plus negative pi over 4 is 0. In both cases, multiplying the moduli and adding the arguments of the 2 numbers give you the same result as multiplying the 2 numbers themselves. You can do the same calculations to find z sub 1, z sub 3. So that's 2 cis pi over 4 times 3 cis pi over 2. 2 times 3 is 6. Pi over 4 plus pi over 2 is 3 pi over 4. For B, how can you prove that your pattern holds for every pair of complex numbers? So I multiply 2 complex numbers, r cis alpha and s cis beta, to see if this pattern actually holds true. When I multiply through, I apply what I know. So I'm multiplying r times cosine alpha plus I sine alpha times s cosine beta plus I sine beta, which when I use the associative property, I can rearrange a couple of things. I can take out an r, which gives me r times cosine alpha plus I sine alpha times s times cosine beta plus I sine beta. Then I can use the commutative property. So I can put the r and the s together. So I have rs times cosine alpha plus I sine alpha times cosine beta plus I sine beta. And I use the distributive property, which gives me rs times cosine alpha cosine beta plus I cosine alpha sine beta plus I sine alpha cosine beta plus I squared sine alpha sine beta. Rs times cosine alpha cosine beta minus sine alpha sine beta. So I just combined my like terms there. Remember that I squared gives me 1, negative 1. And then plus I cosine alpha sine beta plus sine alpha cosine beta. Okay, I use the sum formulas, rs times cosine alpha plus beta plus I sine alpha plus beta. So I get rs cis alpha plus beta. So I get r cis alpha times s cis beta equals rs cis alpha plus beta. All right, let's try it. Find the product of 7 cis pi over 3 and 2 cis negative 5 pi over 6 in polar and rectangular form. All right. So the first thing that I want to do is I want to apply what I just learned. So I'm going to do 7 times 2, which equals 14, and then pi over 3 plus negative 5 pi over 6. Okay, so that's going to be, I need to change pi over 3, so that's 2 pi over 6 minus 5 pi over 6. So 2 pi minus 5 pi is negative 3 pi over 6, which does simplify to negative pi over 2. Okay, so I would have 14 cis negative pi over 2. Okay, and then when I write this in, so negative pi over 2 is 0, 1. Okay, so remember I'm taking 14 cis pi over 2 is 14 cosine negative pi over 2 plus 14 I sine of negative pi over 2. Okay, and that's going to give me 14 times my cosine of negative pi over 2, which is 0, plus 14i times negative 1, which gives me 0 minus 14i, which equals negative 14i. So those are my two answers. I have 14 cis negative pi over 2 or negative 14i. All right, use polar form to multiply complex numbers. An example 4. What is the product of z sub 1 equals negative 1 plus I square root of 3 and z sub 2 equals 5 square root of 3 over 2 minus 5 halves I? Okay, so here is negative 1 square root of 3i, and here is 5 square root of 3 over 2 minus 5 halves. Express each complex number in polar form. Okay. So again, I square each of these. So I get negative 1 squared, which is 1. Square root of 3 squared is 3. So that's 1 plus 3, which equals 4. Square root of 4 is 2. The tangent theta equals negative square root of 3. So tangent, the inverse tangent minus the square root of 3 equals negative pi over 3. Since negative 1 plus I square root of 3 is in quadrant 2, I add pi to result to obtain 2 pi over 3. So 2 cis 2 pi over 3. Then I have this, square root each one, I end up with 5. Tangent theta sub 1 equals negative 1 over square root of 3. Remember, I'm taking the sine divided by the cosine and simplifying it. So I get these negative square root of 3 over 3. Well, the inverse tangent of negative square root of 3 over 3 is negative pi over 6. Since 5 square root of 3 over 2 minus 5 halves I is in quadrant 4 within the domain of tangent negative 1, theta sub 1 equals negative pi over 6. So z sub 2 equals 5 cis negative pi over 6. Okay, so step 2 is I multiply using the formula. So r times s, cis alpha plus beta. So z1, z2 is 2 cis 2 pi over 3 times 5 cis negative pi over 6. 2 times 5 gives me 10. 2 pi over 3 minus pi over 6 gives me pi over 2. So I end up with 10 cis pi over 2. When I solve this out, I get 10i. All right, let's try it. Use the complex numbers z sub 1 equals I square root of 2 and z sub 2 equals negative 1 plus I. Express each number in polar form. So for z sub 1 equals I square root of 2. So I'm going to take, so really I have 0 and then the square root of 2. So that means I have the square root of 0 squared plus the square root of 2 squared, which equals the square root of 0 plus 2, which equals the square root of 2, which we're just going to leave like that. Okay, and then I find the tangent theta of my sine over my cosine, which is square root of 2 over 0. So this is actually undefined. Okay, so I know that there's no cosine, so that means my cosine of whatever has to be 0. Well, the only cosine that gives me 0 are pi over 2 or 3 pi over 2. And since I have square root of 2, that's going to put me with pi over 2. So tangent theta equals pi over 2. So I have for z sub 1 equals the square root of 2 cis pi over 2. And then for z sub 2, we're going to do the same thing. So I'm going to take the square root of negative 1 squared plus the plus 1 squared equals the square root of 1 plus 1, which equals the square root of 2. Okay, and then in order to get negative 1 as my cosine, That would put me at 3 pi. So I have tangent theta of 1 over negative 1, oops, which equals negative 1. So my cosine is negative 1, but my sine is 1. So this is going to be 3 pi. Three pi over 4. Because the only way to get tangent, I don't have a point where my cosine is 1 and my sine is negative, or my cosine is negative 1 and my sine is 1. But I do have a tangent where I get negative 1 when I solve it, and that's at 3 pi over 4, because the square root of 2 over 2 divided by the negative square root of 2 over 2 gives me 3 pi over 4. Okay, so for z sub 2, I have the square root of 2 cis 3 pi over 4. Okay, and then I want to find the product of z1, z2 in both polar and rectangular form. So z sub 1 was square root of 2 cis pi over 2. And z sub 2 equals the square root of 2 cis 3 pi over 4. I'm multiplying these together. I'm going to take the square root of 2 times the square root of 2, which equals 2. Then I'm going to add pi over 2 plus 3 pi over 4. That gives me 2 pi over 4 plus 3 pi over 4, which equals 5 pi over 4. So then I would have 2 cis 5 pi over 4. Okay. This becomes 2 cosine 5 pi over 4 plus sine, or I sine 5 pi over 4. So that's 2 cosine of 5 pi over 4 is negative square root of 2 over 2 plus I sine 5 pi over 4 is negative square root of 2 over 2. So that gives me negative 2 square root of 2 over 2 plus I plus I actually 2 plus 2 negative plus negative 2I square root of 2 over 2. Okay, so this will simplify. So I have negative square root of 2 plus minus I square root of 2. This is going to give me my final answer. All right, example 5, use polar form to raise a number to a power. What is an efficient way to calculate a power of a complex number? Calculating powers using rectangular coordinates can take many steps. So a plus bi to the nth equals a plus bi times a plus bi until you get a plus bi. I'm multiplying a plus bi together n times. By using polar coordinates, you can identify a pattern. So for z, I have r cis theta. For z squared, I have r cis theta times r cis theta, or r squared cis 2 theta. For z cubed becomes r cubed cis 3 theta. So note that z cubed equals z squared times z. So z to the nth equals r to the nth cis n theta. So I find z to the 4th, where z equals 4 minus 4i. So I'm taking 4 minus 4i to the 4th, which would give me 4 square root of 2 cis negative pi over 4. So I converted it to polar form. So I'm taking 4 square root of 2 and I'm raising that to the 4th power. And then I'm taking cis and then I'm moving that 4 down in front times negative pi over 4. So this gives me 1024 cis negative pi. In rectangular form, z to the 4th equals negative 1024. Using polar coordinates can be the most efficient way to calculate the power of a complex number. So let's go ahead and try it. Use the polar form to find the square root of 3 minus I to the 8th. Write the power in polar form. And then I'm going to write the power in rectangular form. All right, so I'm taking the square root of the square root of 3 squared plus negative 1 squared, which is going to give me the square root of 3 plus 1, which equals the square root of 4, which equals 2. So tangent theta equals 5 pi over 4. So this is going to give me tangent of theta equals negative pi over 6. So I get 2 cis negative pi over 6. So then z to the 8th equals 2 to the 8th cis 8 negative pi over 6 because I'm applying the formula. So this will give me 2 to the 8th equals 256. And then 8 times negative pi over 6, well, simplified, gives me negative 4 pi over 3. So from there, I'm putting that in a rectangular form. So if I were to take take 256 cosine negative 4 pi over 3 plus 256 I sine of negative 4 pi over 3. Okay. So cosine of 4 pi over 3 is negative 1/2. So 256 times negative 1/2 plus sine of negative 4 pi over 3 is negative square root of 3 over 2. 256 negative square root of 3 over 2. Okay, so when I multiply that through, I get negative 128 plus 128i square root of 3. Concept summary, using the polar form of complex numbers. So I have equations, rectangular form, z equals a plus bi. Converting to polar form, I have r equals the absolute value of z, which equals the square root of a squared plus b squared. Tangent theta equals b over a, so theta equals the tangent, inverse tangent of b over a. My product formula, r cis alpha times s cis beta equals rs cis alpha plus beta. Polar form, I have z equals r cis theta. I can convert to rectangular, so a equals r cosine theta, b equals r sine of theta. And my power formula, z to the nth equals r to the nth cis n theta. And there's my graph. And that is the end of Unit 8, Lesson 5.